Good morning. I am Judith from Physical Science Department. Now, today we are going to discuss a topic about mechanical properties of solids and fluids. Let's see about the properties of solids. In solids, atoms or molecules are tightly fixed in the solid formation. Atoms get bound together through various types of bonding. Due to the interaction between the atoms, they position themselves at a particular inatomic distance. This position of atom in this bond condition is called their mean position. Now let's see about the plasticity and elasticity. Elastic behavior of materials. The rigid bodies when stretched with an external force restore their original shape after the removal of this force. It means they are in an elastic limit. So until the elastic limit, the body resists the changes. Therefore, we can say that the body is perfectly elastic. Now let's see about plasticity. Plasticity is the property of solid material and it does not gain its original shape and size after the removal of applied force. Plastic wrap is an example of plasticity. After stretched, it stays stretched. Now let's see about the stress and strain. Stress. When the deforming force is applied to an object, the object deforms. In order to bring the object back to its original shape and size, there will be an opposing force generated inside the object. This restoring force will be equal in magnitude and opposite in direction to the applied deforming force. The measure of this restoring force generated per unit area of the material is called stress. Thus, stress is defined as the restoring force per unit area of the material. It is a tensor quantity denoted by a Greek measured using Pascal or Newton meter square. Now let's see about strain. Strain is the amount of deformation experienced by the body in the direction of force applied divided by the initial dimension of the body. Now let's see about Hooke's law. Hooke's law states that the strain of the material is proportional to the applied stress within the elastic limit of the material. Mathematically, Hooke's law is commonly expressed as F is equal to minus K into X, where F is the force, X is the extension in length, and K is the constant of proportionality known as the spring constant in Newton meter. Now let's see about the moduli of elasticity. The modulus of elasticity is simple, the ratio between stress and strain. Elastic moduli can be three types. Let us see about rigidity modulus or shear modulus, bulk modulus. And from the properties of solids, pressure of a fluid. Fluid pressure refers to a measurement of the force per unit area that acts on an object in the fluid or on a closed container's surface. Furthermore, the cause of this pressure is due to acceleration, gravity, or by forces that are outside the closed container. Now let's see the diagram of the pressure fluid. Then discuss about Pascal's law. Pascal's law expresses that the pressure or power of pressure at a point in a static fluid is equivalent toward all paths. It expresses that in the event that pressure is applied to a non-flowing fluid in a container, that pressure is transmitted equally throughout the inside of the container. And the buoyancy force. Let's see the diagram and hearing the words. The upward force exerted by a liquid on an object immersed in it is known as buoyancy. When you try to immerse an object in water, then you can feel an upward force exerted on an object, which increases as you push the object deeper into water, as shown in the picture. Now let's see about Archimedes' principle. Archimedes' principle deals with the forces applied to an object by fluids surrounding it. This applied force reduces the net weight of the object submerged in a fluid. The upward buoyant force that is exerted on a body immersed in a fluid, whether partially or fully submerged, is equally to the weight of the fluid that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. Now let's see about the viscosity. Viscosity is the tendency of a fluid to resist any change in its shape or motion. It is a measure of the internal force of a fluid. The internal forces or friction of fluid comes into play when one layer of fluid is subjected to move over another layer. Now let's see about streamline flow. Streamline flow in fluids is defined as the flow in which the fluids flow in a parallel layers such that there is no dispersion or intermixing of the layers, and at a given point the velocity of each fluid particle passing by remains constant with time. Now let's move on to the surface tension. Surface tension is the amount of energy required to increase the surface of the liquid by unit area. In other words, it is also the property of the liquid surface that resists force. Intrinsically, it keeps a barrier between foreign materials and liquid. This is the force that holds the liquid molecules bound together. Now let's move on to the Bernoulli's principle. Bernoulli's principle states that the total mechanical energy at a moving fluid comprising the gravitational potential energy of elevation, the energy associated with the fluid pressure, and the kinetic energy of the fluid motion remains constant. Bernoulli's principle can be derived from the principle of conservation of energy. Let's come to the conclusion. We can see about mechanical properties of solids. In mechanical properties of solid, we see about elasticity and plasticity. From that, we see about stress, strain, Hooke's law and elastic moduli. From elastic moduli, we can divide it that Young's modulus, shear modulus and bulk modulus. Then we see about properties of fluid. In properties of fluid, we can learn about surface tension, streamline flow, pressure of a fluid, Pascal's law, buoyancy, Archimedes principle, viscosity, and Bernoulli's principle. These all are we learn about the properties of fluids. So thus we learn in today's topic that properties of solids and fluids. Thank you all.